sure everybody's from Ghana. Okay, cool. That's fantastic. Cool, guys. Well, look, from my side, myself and I'll let Zippy introduce herself. My name's Gareth. I'm Gareth Bowers. I'm a AWS Solution Architect as well as a software developer by background. I'm also CEO of Silicon Overdrive. And myself and Zippy today, we're here to just chat to you about cost optimizations and various things to consider, and things that won't obviously be an exhaustive list. It's more of a level 100 kind of top level conversation, because there's a lot of things, and we'll probably want to do more than one sort of presentation to cover the topics, the slightly more advanced things at the level 200 or 300 next session. But otherwise, let me hand over to Zippy to introduce herself.
Awesome. Thanks, Gareth. Good morning, everyone. My name is Zipporah Wachira, but I typically go by Zippy. So I currently work as an AWS Cloud Solutions Architect at Silicon Overdrive, and I'm also an associate AWS ambassador. So very, very glad to be here.
Cool. Do you want to maybe start then, Zippy? I think we've given people enough time.
Yep, I can kick off. Give me a moment. Okay, guys, so today we're going to be looking at cost optimization on AWS. We're going to be giving, or rather looking at one, what are the things to consider, what are the things to think about, the factors to consider from a cost optimization perspective, a few tips and tricks based on our experience on how to optimize costs. This would be both post and pre-deployment, and a few other items. So just to note, as Gareth has mentioned, this will be more like a two-part webinar. So today we're going to do sort of the basics of cost optimizations. Then we'll have a follow-up session where we're going to go into more of cost optimization from a modernization perspective. So that is what we have in store for today. And these are just the items that we're going to be looking at. What are some of the cost drivers for different services? How do you forecast cost on AWS? Designing for cost optimized architectures, monitoring and visibilities, and then we'll go into some specifics of, for example, how do you actually cost optimize on storage? How do you cost optimize on compute? How do you cost optimize on databases? So a few more specifics for the different resource types. So first things first, before we go into, I think one of the challenges that I've seen from the few exercises that we've done in terms of cost optimizations for our clients. So sometimes we have clients who come to us and they're like, we deploy this, and this, and then our costs have inflated greatly over a very short period of time. It's like, we don't see what's causing this, and this. And often when we go into the account and do a bit of an assessment, what we find is that the basic infrastructure, the very setup that was done at day one is what is really causing the problem. So when we think about cost optimization, it's very easy to jump into what is well known. So start thinking about, maybe I need to do the reservations, maybe I need to set up some sort of discounts, maybe I need to reduce the number of instances running in my environment. But often what people tend to forget is that there is a step before that. Before you even get into deploying, there's factors that you need to consider before you even get to that point. And there are things you need to put in place to make sure that even when you go now and deploy your applications, your infrastructure, your systems, and whatever else it is that you're running within the AWS cloud, you have already put measures in place to ensure that your costs are going to be manageable, your costs are going to be predictable to a certain level. So we are going to look at this from two perspectives: pre-deployment and post-deployment. So what are the things that you need to consider before deploying or provisioning any services in the AWS environment in terms of cost optimization. And then once you provision your services, you're running your infrastructure, now what are the things that you can improve to better manage your costs? So for pre-infrastructure deployment, first things first. And again, something that I've seen a lot of people make a mistake of is not understanding what it is that you're charged for in AWS. And this is quite critical because it's one thing to go and provision a resource, and it's another thing to know that for this very specific resource, I'm going to be paying for this item, this item, this item. It even helps to understand because when you go now into your bill, there's usually a breakdown that usually shows you the specific items that you're paying for. But without this knowledge beforehand, it will be very hard even to interpret what it is that you're paying for. So one of the key things that you need to start off, your step one essentially is understand for a specific service what it is that you usually charge for. So how AWS, the AWS pricing model, it of course differs from service to service. So for example, you find that for a lot of the compute services, you usually charged on items such as the instance type that you're running, the duration, which is typically charged per hour, and then the specification. So for example, the number of vCPUs assigned, the amount of memory that's assigned to that resource, the amount of storage. And then if you look at things such as networking, the cost metrics, then they are different. There you're being charged for largely for data transfer between your zones, between your regions, data transfer outside, which we call the data egress. Then your databases, you're going to be charged for example, your the instance size that you're using, the type of storage that you're using, the read and write patterns for that particular databases. So it differs. And one of a very easy way to understand upfront what it is that you're paying for, if I can just bring up a page. So for any service that you're running, AWS typically has a pricing page that usually has a very detailed breakdown of what are the specific cost metrics for that particular service. So for example, let's say I want to know what will I be charged for a MySQL database. So if I search for RDS pricing, there is usually this page, the pricing page for any and all services. So if you go into this page, then it shows you the breakdown of the specifics of what you're going to be charged for. So if I can choose maybe a specific engine, let's say MySQL, first things is, expand this. The instance type that I would have selected, then I can see what exactly is that price per hour for that particular instance size. For the reservations, if I reserve that particular that database instance, then how much am I saving? Then I can see I'm also going to be charged for storage, and I can see that this is what it's going to cost me. For GP3, this will be the IOPS per month. This is a storage per month. For backup storage, then there is an explanation there, a very detailed breakdown of how backup is actually costed for databases, your snapshots, if you're going to export, how much that is going to cost you. So any and all services that are on AWS, there is an associated pricing page for that particular service that you can use as your baseline to start and go and look into what exactly is it that I'm going to be charged for. And this is one of the ways that you can get around what people usually term as hidden costs, cloud hidden costs. It's not so much that there are any hidden costs, it's just that there are certain things that may not be immediately transparent, but this would be where you get to understand what are those other things, apart from the obvious things that I know obviously I'm going to be charged for my instance, but what else am I going to be charged for? So this is one of the ways that you can understand that. So this would apply for any and all resources that you'll be running in your AWS environment. Then the other thing is now on support and for most of the accounts, so we know we have different layers of support or different tiers of support for AWS environment. There is the most common that comes by default, which is the free tier, but it's also key to note that there are other tiers. So that is also something you can look at if you may find someone may have upgraded you to maybe a business tier, which is a charged tier. So that's also a cost to think about. Do you need that support? What level of support do you need? And then how much is that going to cost you in any given month? Then management tools are the services that you typically use to for account administration. So think of services such as your CloudTrail, your CloudWatch, your GuardDuty, whose costs are usually largely tied to the level of activity in your environment. So again, first bit, understand how are these services going to actually be charged? What are the cost metrics essentially? And then match that against the expected level of activity in that particular in your particular environment. So that will be the first bit. Then the next bit pre-deployment is on forecasting. So the good news is it's possible to get a view of your anticipated spend on AWS. Again, this is pre-deployment. And AWS provides a very handy tool, which is called, the AWS Pricing Calculator. So what the pricing calculator does is it allows you to define your workload or to define your service in the form of the specific resources that you're going to utilize. And it allows you to specify the different metrics for which you're going to use to provision that service. And then it gives you the expected cost for that service. So again, if I can just demonstrate that very quickly. If I go to the AWS pricing calculator, so this is what it looks like. So what I would need to do is specify the service. Any and all services would be included depending, any and all services. So let's say, for example, I want to launch an EC2 instance. I'll specify EC2, then I'll also need to specify what region do I want to provision this instance. Is it Cape Town, Ireland, somewhere in Asia? So you can change that depending on where it is that you want to provision that instance. Then I can now go into the specifics of how I want to provision this instance. How many instances do I want? Do I want one? Do I want two, three, however many? And then what are the resource specifications that I want to provision for this instance? So for example, I want an instance with 2 vCPUs. I want an instance with 4 gigabytes of memory. So I can already see the different options that I have. So for example, if I pick a T4G medium, then I can see that's going to cost me $24. If I pick the T3A medium, then that's going to cost me $27. So the different, you can, first things, you get a view of what are the different options, and you can see they differ based on not just cost, but also the technology, the underlying technology that's being utilized. For example, this would be a Graviton instance. So if you're not looking for a Graviton instance, then you can choose a standard T3 medium instance. But at least you get a view of what are the different options that you can utilize. Then the other very handy thing that you get from the calculator is that you can view pricing from across the different pricing models. So I can start with, I want to see what is my on-demand cost for my T3 medium instance, and yeah, for 2 instances. So it's about $60. So what happens if I utilize the EC2 savings plan, then what is my resulting cost? That brings me down to $26. What if I reserve that for 3 years? Then that gives me about $26. So you can compare the different pricing models to identify upfront which is the most optimal for the service that you're wanting to launch. Then I can specify my volume. Maybe I want 50 gigabytes of storage. And then finally, what I have is a view of what is this instance going to cost me? If I provision this instance in my account, I expect that at the end of the month, I'll have a bill of 34.28 US dollars. So you can do this for any and all services that you want to launch. Critical thing to just note is make sure that when you're creating this estimate, you create it in the correct region. So the region where you're actually wanting to provision, because as we know, pricing tends to differ by region. So if you want the most accurate estimate, then make sure you create that estimate in the region where you want to provision your resources. So that is the other thing. One, whether you can actually forecast your AWS cost. Of course, there will be times where there will be changes in the actual environment. There are always some unexpected items, some unexpected events here and there, but this gives you a starting place. And if you think about it, even from a budgeting perspective, you can actually start to identify, so this is the range for which I should budget for this number of resources or for this kind of workload. It's probably going to cost me between this amount and this amount, and then you can budget for that. Then the other item now is on the architecture, how you actually define your architecture. And why this matters is that, one, there are different architecture patterns that are available to you. For any given workload, there are different architecture patterns that are available to you. So another critical item, another critical factor to think about is which pattern best aligns with my requirements. And then you also have to weigh that against what is the resulting cost of that pattern. So some patterns are going to be more cost effective as opposed to other patterns. So for example, if we look at compute, which is usually a very good, a good one to do a comparison. If we just look at compute specifically, you have options such as your EC2, which is a very standard virtual machine. And then you can also opt to containerize your workloads, and which now opens up other options. Now you can host that on either the container service or on the Kubernetes service. You can further refactor that and choose to, let's say you want to just use what are they called? Functions that are run based on a trigger or based on an event, in which case then you can leverage Lambda. So the thing is, again, going back to understanding the pricing metrics, the first item that we looked at. For your EC2 instances, this is a virtual machine is something that's going to be running throughout. So this is something that you're going to be paying for. Even when you turn it off, we know that you still pay for storage, though you don't pay for compute. But a VM typically tends to run continuously. Then if we look at, now if we move to containers, one of the key advantages that we have for containers over virtual machines, one of the key advantages that we usually indicate is that containers tend to be more resource effective, which means if an application that can be deployed on a virtual machine using maybe a virtual machine of, let's give it maybe 4 vCPU with around 16 gigabytes of memory, when that is refactored into microservices, that can be hosted on a very small containers that could consume probably 1 vCPU with 2 gigabytes of memory. So they're ultimately more effective in terms of the resources, and hence containerized environments, they tend to be cheaper. To a certain extent, they tend to be cheaper than standard virtual machines. So that is again something to consider. Then if we go to more serverless kind of setup, so think of your Lambda, these are things that are typically event driven. So a function will only ever run when it's triggered, which means you only pay for it for the period when it is running, and you don't pay for any other time. So again, that even brings your cost even further down. So all these are different architecture patterns that you can take, and all of them have different costing metrics. So a key things that we tend to advise our clients is there is where you start from. A lot of the clients that we interact with tend to start from a virtual machine kind of environment. A virtual machine based kind of environment. But then for we have to also look at what we call modernization down the line, which is if you think about it from a business perspective, it's as your business grows, you're wanting to also gain more efficiencies, even for your technology. So there is where you start, but then you need to grow towards efficiencies. And that means that yes, there is where you start, there's the architecture you start with, but you also start modeling a path towards better efficiency. So that means building a path or paving a path towards more of a microservices-based architecture, more of a serverless kind of an architecture. But of course, this also boils down to the application that you're deploying. Some would be better suited to one architecture as opposed to other architectures. So the key thing here is, one, understand what are the different patterns or what are the different options that you can take. What are the options that are available to me to host a specific system or a specific application, and then which one is the system as it is right now, how can I actually host it? Which one of these patterns best aligns? And then now you have to think about next steps, future. How can we transition? Is it possible for us to transition to something that is more cost effective, that is more, gives you better performance, gives you even better resource utilization? So understand those different patterns. And this applies even to other resource types. So even if you think about your storage, if we take, for example, S3 buckets, it's very well known that S3 tends to have the different classes of storage, where you have your standard being very expensive, you have your Glacier being more cost effective. So again, upfront when you're designing your architecture, if you have data that gets stale over time or data that needs to be archived over time, then you can start from the design stage indicating that we are going to leverage the different storage classes, where you can set up your life cycle transition, so that even just from your design, you're already thinking of your cost, how to actually optimize your cost. So your active data, you'll pay higher for that in standard, but you also have that being transitioning into your Glacier. And a lot of these services, the storage services, even EBS, EFS, a lot of them tend to have the option for cold storage, which usually costs less, and you can transition some of your data. So these are the things to actually think about, is what are the different options that are available for me, and how do those align to my current requirement for the system that I'm wanting to move, or the application that I'm wanting to host within the AWS environment. Okay, so those are the three critical things when you think about pre-deployment and what are some of the items that you can put in place just to make sure that your costs are going to be optimized. Then the next bit now is, okay, so now you've understood the pricing model for the services that you want to deploy. Let's also say you've created your pricing estimate, you have a view of what to expect after deployment, and then you've identified the pattern that's going to fit your deployments, whatever pattern it is that you're going to leverage. So now, post-deployment, once you have provisioned your resources, once your applications, your systems are up and running within AWS, now what do you do? What are the tools that are now available to you for you to manage your costs? So one very, very critical one that this would actually might even fall into pre-deployment to a certain extent, but budgets is a critical item before you even get anything up and running. And this is why it's even important to do that estimate, to do the forecast, so you have a view of what is the amount that I'm expecting to spend. And that is what is going to inform how do you set that budget, what amount do you set for that budget. And then what this does is that now your spend is going to be monitored automatically. And when you hit that budget, you're going to get a notification that your spend is either almost hitting the budget or it has hit the budget that you have specified. So again, quite critical to just do a cost estimate. So it really doesn't matter whether you're just provisioning a test instance, just to test a few things to mess around with. So just try to get a sense of how much would this cost. And for a personal account, for example, a critical thing is you can set it maybe not so much for a specific service. Like for example, for my personal account, how I've set a maximum of $5 in a month. That is my budget. So I know no matter what services I'm using to test and whatever services I provision, I should never spend in any given month more than $5. So that is also very critical, especially for for a personal account that has exceeded the free tier. So you're actively paying for services. So that will help you to keep track of what are you actually provisioning and how much is that actually costing you. Then there are other services that are available to you. So the billing dashboard is where you can now view the resources that are provisioned in your environment and what is the associated charge for that. Cost Explorer typically gives you more of a graphical view and gives you a more granular sort of an interface, so allows you to filter based on different metrics, based on different patterns. So this is where you can visualize for a period of time. Let's say I want to see my spend for the last 3 months. Let's say I want to see my spend for just a specific workload. I want to see my spend for just a specific, maybe just my compute services, or maybe just I want to just see the databases. So essentially, it has more fine-grained metrics that you can use to filter and view your spending patterns over time. Then we also have, we call the cost anomaly detection. So this is more of an ML-based model that it tracks your spending patterns over a period of time. I think it usually collects data, if I'm not wrong, from around the past 90 days, and then uses your spend patterns to identify a cost anomaly. So this is again something very nice, because if you think about these cases that we've had in the past where, let's say, your account gets hacked and someone goes and launches a big instance and that starts using that for Bitcoin mining. So that's something that's going to be detected as an anomaly, because based on your spend patterns, you typically don't accumulate that kind of spend over a period of time. So that is identified as an anomaly, and you can get a real-time alert allowing you to go into your account and actually look at what that anomaly is and whether it is something that needs to be there, if it's something that needs to be remediated. Then you also have CloudWatch. This is more for performance monitoring. but also helps with keeping track of the resource utilization of your the different services that you're utilizing. So remember, back to the first slide, we were looking at what are the cost metrics. So for example, we saw for databases, it's something like what is your IOPS rate. So the CloudWatch is the one that would actually be able to show you, for the instance that you have provisioned, this is your rate, or this is how much traffic this particular service is actually getting in. This is how much of your CPU maybe is utilized. This is how much of your memory is consumed. This is how much of your storage is consumed. So it also starts to give you a view of whether your instance or whether your that particular service could be over provisioned or under provisioned. And CloudWatch becomes quite handy where you start to have performance issues with your resources or with your applications, because in most cases that tends to be related to the resources that are assigned to that particular resource. But it can also give you a view of whether an instance is being fully utilized or whether it's been underutilized, and then that will tell you, are you paying more than you need to? Do you need to pay more for that particular resource? So Gareth, I'm going to hand back to you for the last bits.
Thanks, Zippy. Let me share screen. So I think the real key to, let me move that off there. I think the real key to really understand from a lot of what Zippy's spoken about is there's so many AWS services that you also really want to make sure that you're considering your things on the pre-architecture deployment side of things, so that you have a good understanding of the options available and understanding that there's quite a bit of depth to some of them and really kind of things. So the shout out about the budgets is phenomenal. Yeah, I highly recommend that. Okay, so some of the additional tooling and the stuff there that is available. So once you have set up your account and your stuff on AWS, there are multiple tools and ways to kind of help you keep an eye on what the costs are and what's happening from them. So AWS provides a tool called AWS Compute Optimizer, which helps recommend optimal compute resources. There are multiple tools that assist with these sort of recommendations, and they will pick up things like, if your compute seems unutilized or over provisioned, in other words, the CPU seems largely under 10% or 5% and stuff. In other words, it's not really utilizing the size that can probably be reduced 1 or 2 instance sizes and save you money. Maybe you've only got a small amount of disk space being used on EBSs, in which case, again, maybe it's over provisioned. It looks for certain things where it maybe can optimize or recommend better things that can be identified or things that aren't being utilized. Maybe you've spun up certain services that just are getting no traffic or not connected. Maybe you've got a load balancer or something that's not connected to anything. So those sort of things where Compute Optimizer can really assist, as well as various of the other tools and stuff that highlight the similar thing. We always find that it's useful to use more than one tool, simply so that you get a sense of which one is making, or if the recommendations are overlapping, so that you also get a better sense of the recommendations and can better investigate your own workload to get a sense of what it's doing and stuff. The obvious things in terms of being able to optimize your compute costs are things like savings plans and pricing models. These are specifically more suited to a slightly more mature workload where you've kind of already gone through the exercises of Compute Optimizer and various other recommendations, and you're effectively sort of happy with what is running in your workload, and therefore you're prepared or happy to commit to a savings plan or reserved instance. Savings plans and compute plans are more flexible. They will give you a discount on your spend based on your spend itself. It doesn't really matter if it's a a T3 large or a C5 large or what sort of EC2 you've got, you will get the saving. Whereas a reserved instance will give you a slightly higher percent saving, but it won't necessarily give you the same level of flexibility. So for instance, if you wanted to change family classes or various things like that, then you might find that the reserved instance might have certain limitations where you need to stay within the family class and stuff like that. So again, it's very good to just understand what's available for them, and then make sure that you understand what the time frame is. You can go for no upfront commit. You can go for a 1 year, a 3 year, and therefore you can actually get some much higher percent discounts, but then you just need to understand what the commitment is or what your thing is. So again, from our side, that's something that we would recommend once you've got a good understanding of your user base or what your workload's doing, how it scales, what the expenses look like. In other words, it's a bit more of a mature workload than something that maybe you're still developing or haven't yet launched and stuff. Then more specifics in terms of, again, going back to maybe what Zippy was looking at in terms of the pre-deployment considerations is to optimize your storage. There's a lot of ways of doing so. The simplest is always to chat to an AWS partner like ourselves, or get a reasonable idea of the services, read up around them so that you've got an understanding, use the cost calculator, and then when you're building it out, be prepared to do like a little POC or a proof of concept and test 2 or 3 things to see if your workload actually utilizes it like you think. So the obvious things would be things like, where do you put your storage? So if your application wants to upload user data, are you using EBS? Are you using EFS? Are you using S3? EBS is local storage behind the EC2. EFS is great if you've got, stateless servers that maybe scale out in an auto-scaling group so that you can share the storage behind it. That's a very common pattern for something like maybe Moodle or WordPress or something, where you're maybe dishing out courses or content that you want to one location where everything is there. It generally will be a better, easier, faster method, and trying to do it on EBS then requires you to synchronize the data behind it. S3 is another option, but sometimes you might find that block storage isn't necessarily as efficient as the EFS, and obviously you get the Windows equivalent as well for the EFS and stuff. But effectively, it's about trying to understand where does that sit and what pattern makes the most sense. Then pick the correct storage. Again, there's loads of options for the different tools or the services. So like, for instance, S3 has brought out quite a few new versions over the last while. So you now have not just the standard and the infrequent access and the one zone, you have intelligent tiering for where you don't know how exactly your workload will be, and therefore it moves the files between standard and infrequent. You've also got your Glacier instant retrieval, flexible retrieval, and deep archive, which can give you a great saving if you're not needing to use the files on a regular basis. So if you do want them to be available, but you don't think you'll need them very often, like maybe log files that are more than 30 days old, you might need, and when you do need it, you might need them quite soon. So maybe instant retrieval would be a better option. Maybe if it's to do with copies of your database that you don't think you'll need, but you need to keep for compliance reasons, maybe a deep archive would be a better route, or things like that. Sometimes you might find that you've got compliance there. You need to keep things for 2 years or 5 years, but in reality, you don't really need to put it back on a regular basis, and therefore you're prepared to wait a couple of hours to pull it back. You might find that getting a substantial saving makes a lot more sense to move it there. And similarly, you'll find that you've got similar options for things like the EFS and the EBS and those sort of things. And that really just is, understand the product options. Like on EBS, you've got GP3 versus GP2. You've got your different cost savings. One of them comes with GP3 has a out-the-box 3000 IOPS, so your input outputs, whereas your GP2 is your older school, and you've got 1 IOPS per 3 gig or 3 gigs per 3 IOPS per 1 gig. So if you've got 100 gig GP2, you'll get 300 IOPS. Whereas if you convert that to a GP3, you'll naturally get 3,000. So you'll get 10 times the performance, and it will actually be cheaper per hour. So that really and truly, there is no reason to really run a GP2 ever. It's one of those things that, it always makes sense to kind of upgrade as you go along, take advantage of the newer, cheaper technology and stuff. Something else then that you'll see often is things like provisioned IOPS. Equivalent thing on Lambda would be like provisioned concurrency. Be aware of them, test them out, but also be aware that they do come with a price point that's higher than the normal. And you generally would want to test them out to understand, is your workload really needing it? How does it work without it? And therefore, what is the price point with it? So that you really just kind of understand it. And again, I can't encourage enough to just kind of do a bit of a POC or test both options if possible, if time allows and stuff. The other thing that we see a lot that people don't always implement, because when you're busy developing it and getting ready to go live, you're not thinking about it because it's not an immediate concern. But at some point, that data will become old or longer term, in which case having lifecycle rules can hugely save money. So for instance, let's say that you're making regular snapshots of your server as you go along, or your EBS as you're making backups, or even your database, you're making things. And you take 6 months, a year to develop the application, and then you go live, and then a year later, you still maybe are sitting with snapshots of stuff that was there for development from 18 months ago, or then a year's time, it's 2.5 years. At some point, there's absolutely no value because you're not going to want to, go back to that sort of a version. You kind of all, assuming that you'd only ever really want to go back to something within the last few months or whatever. So lifecycle rules is just an easy way, and you can implement them in a multiple of services, but the most common is obviously S3 and your database and restore stuff, where you can naturally set it up so that anything over a period of time will maybe move from S3 into Glacier, or from Glacier get deleted, or things like that. So you can set it up so that you don't have to manually assume that your sysadmin or your developer is going through and doing cleanups of your account or removing things like you would in a normal sort of on-premise environment and stuff. Then in terms of optimizing your database costs, this is also a huge thing where we often will see that the bulk of somebody's costs will either normally be the database or the compute, or the combination of the two. So really just kind of, again, planning and understanding the types of databases is key. First and foremost, you kind of are wanting to get a sense of, does your application work better with a relational database structure or a node database structure? Do you need a commercial database engine? Is that requiring a license or a no license? AWS has a lot of cloud native databases that they have built themselves. I haven't put all the lists here, but obviously there's DynamoDB, but there's a lot of others. There's a TimeStream database, there's Neptune, and there's a lot of the other ones that maybe are more focus built, like TimeStream is actually incredibly useful if you're doing something that maybe you want specific time points for the things that maybe you could do in a relational, but maybe the price point and the amount of effort to code isn't worth it. And maybe there's a more cloud-specific database that will help you achieve what you want. Similarly, then, if you are using a licensed product, like maybe Oracle, Microsoft SQL Server, even MongoDB, you might find that there are certain things which work where you want to just say, look, for development, we want to pop the database on an EC2. RDS does cost more per hour than running it yourself on an EC2. However, RDS gives you a lot of options where you can simply enable encryption at rest and high availability. You can spin up read replicas. It handles all that for you out of the box in terms of kind of one-clicks or simple setups, whereas on EC2, it might be quicker and simpler for, in your initial development stage. But at some point, you might say, well, we need to take advantage of the RDS once we go to production, or we then want to set up the HA. And again, you want to maybe see how can we understand what the workload's doing? Do we have enough telemetry or metrics to really understand if the application is slow, and we're trying to now say, okay, we're testing with this amount of data and we're wanting to get to 10 times or 50 times or 100 times the amount of users. And once we launch, we think it will, really grow. We're running this marketing campaign and we're expecting, 5 times the amount of users. Then you want to be saying, well, where is the potential bottleneck? Is it the application reading the database? Is it the database with compute? Is it struggling to process the transactions timeously? Are all of the transactions of a similar nature? If so, maybe we can offload those to a caching engine, like maybe Elasticache or DAX if you're using DynamoDB, and a lot of the services will have their own sort of method of it. So, maybe you've got an e-commerce site and you'll find that 70% of your users will be querying certain products. It makes absolute sense running a caching engine because most of your queries are going to be the same. If you've got a website where people are logging in, viewing their profile and their details and their stuff, none of that really will be cached because no two users will be viewing the same stuff, in which case it doesn't make sense for a caching engine. Then maybe what you might want is saying, can we easily spin up a read replica? What's involved in changing our code or having two database connections or some way of utilizing that the reads go to the read replica, the writes go to the write node, and therefore you don't utilize the compute or the memory on the master node. You rather are just offloading all of the reads to the read replica. Similarly, if you've got maybe like a data warehouse or reports or PDF generation that happens on the back of transactions, that can just as easily be offloaded to query against a read replica, because you might find that if you've got a read replica, you don't need to increase the size of your master, and therefore the price or the cost for running a read replica is less than increasing the size of your master. Same as, for instance, having a proxy, having database connection pooling. Again, it's something that can happen across all forms of compute, whether you've got your Lambda or your EC2 or Fargate or however it works. You might find that running a proxy for your database means that you have less workload happening on the database, you have less database connections getting spun up, and therefore you don't need to be trying to overload it as much, and you rather run a proxy or have the connection handling. In Lambda, you can have things like helper files or various layers where you can keep the connections open. But again, it really depends on the workload and what it's trying to do. But we sometimes see that if people are creating a new database connection per Lambda and your Lambdas fan out and you've got several hundred or several thousand in parallel, the problem is not Lambda. You can set Lambda to scale. The problem will be your database. So how do you make sure that you're either querying it or you're somehow making sure that you've got some way to protect the database from scale? Because permanently paying for a database 24/7 that can handle the scale but isn't needed 20 hours of the day isn't an efficient use of the database. Therefore, you need to kind of understand maybe some of those things can be queued. So for instance, what you might find is Lambda could write, rather than writing to a database, it could write to a queue, and you then have something else that reads the queue and it writes to the database, and then it doesn't matter if it's got 50 or 500 items on the queue, it will then just process, one every so many milliseconds, and it can just process through, and it still follows a FIFO process of writing to it. So there's lots of these sort of little ways of understanding how to optimize the cost, rather than what sometimes happens is there's a lot of pressure, people are in production, something's not working or it's working slowly, and the immediate response is, well, let's just increase the resources. And yes, the problem will go away, but it will go away until there's more users or something else is there. So really, you want to go back when you've got a gap the next day or the next week and kind of really see, okay, what better telemetry or what better metrics can we enable? Is this looking at adding X-ray to the code or performance insights on the database? Do we look at slow running queries? How do we not increase the resources permanently? How do we rather go back to what it was? And how do we then see what is viable options or what needs to be done on the application side, or maybe introducing another service there's lots of queuing mechanisms. AWS has SQS, there's managed queuing services, there's loads of goodies around that to it. We also sometimes see people using Elasticsearch as a method of storing the data in kind of like a fast swappable space. There's lots of those sort of things around it and stuff like that. So it's really just trying to understand what sort of database are you using? Are you fundamentally using the best for it? Or have your developers simply picked the database because that was the one that they knew, or what was the one that was maybe on-prem, and there's been a lift and a shift and not kind of a reconsideration of those sort of things. So that's a lot of what we will also delve into next time. That's more what we would term like a modernization, or kind of the considerations for when something should be maybe re-architected or re-looked at from a deeper level in terms of trying to gain advantages of modernizing it or moving it to maybe more cloud native platform or paradigms and stuff like that. But just, be aware that things like the database specifically, whether it's licensed, can it be moved off to, an open source database, MySQL, Redshift, Postgres, things like that, MongoDB. Can MongoDB run on DocumentDB? Do you want it on EC2? Do you want it on Atlas? Where do you want it looking? Can it move to NoSQL? And possibly, maybe parts of the database can be split. Maybe you'll find certain components can be moved into a NoSQL and you leave the rest in the relational. So there's a lot of those sort of tools that it's really useful to just kind of get a good sense of what is possible, and then go and have a look at the product pages, understand what is there, and just make sure that you understand the costs and how you're structuring it and stuff. And the other thing that is really important to do on a regular basis is just relook at what you have got. What, decisions made today or last year or 2 years ago aren't necessarily the best decisions in 6 months or a year's time. There might be a new product option that now is there. Like, for instance, Aurora Serverless V2 came out not so long ago. It didn't have the ability to shut down completely. Now there is the option for Aurora Serverless V2 to shut down completely, so that you're not paying when it's not being used. You can now set it to go back to zero CPU when it's not there, whereas previously when it came out, it wasn't an option. So you always had a minimum kind of pilot light running sort of story. So again, you need to realize that a lot of the time the services that you're using do change, and the options that you were comparing it against might have improved. So maybe something that you didn't want to consider or discounted because it couldn't do X, Y, or Z a year ago, maybe it can do now. And therefore, maybe it is a better option. Maybe you want to get one of the team to spend a bit of time and just try and POC it or see if it looks like it will add value. But again, it's really about just trying to understand what is the workload trying to achieve, and where are the pain points, and more importantly, what is it needing to do in 6 months or a year's time? Is it going in the right direction so that you can scale without incurring costs, or that you at least are understanding what those costs are and they make business sense and financial sense, so that it's helping get more revenue in to cover it. From our side, as I said, we were wanting to keep it at the 100 level. It's obviously one of those topics that's can be very fun to chat about, because there's so many things that spin off from it, because it goes very heavily into the architecting side as well as the sysadmin side. And that's why we'll do a second session where we go into it more on the 200 or the 300 level and dive in a bit further. But a lot of what me and Zippy have covered has been more what the sort of things you'll cover, a lot of the stuff around the solution architect, and not so much the architect pro, probably more on the architect associate. So it's really just trying to unpack around, the what is possible kind of mindset in terms of, what do you know enough to know what you don't know, so that you know where to go and read up and research and stuff, is maybe the easiest way of putting it.